Yeah.
The 2.5 would be 2 observations of 45 on the stone leaf diagram.
Okay, 2 observations of 45. What do you think? But what do they mean then? Yeah.
I don't know if this is right at all, but I put that they were like the median in the data. I don't know.
Well, we'd have to figure that out. We haven't done that yet. But I'm just asking, how do you interpret? So she's saying there's 2 45s in the data set. You agree with that? What's that? 2 of the same numbers, okay. But what are they? Yeah. 2 of the fishermen had a mercury hair content of 45. 2 of the fishermen had mercury hair content of 45. So don't forget that this is telling us something about something in the world, right? It's telling us something descriptive about something in the world. So it's telling us that in this data set, 2 of the fishermen had a hair mercury content of 45. Okay? Let's see. Any other, just while I'm here, is there any other questions that we should talk about? Yeah.
I have a question on number 5.
5, okay.
Numbers of cars sold, and then you go down and it says total.
Okay. Uh-huh.
How would you do that? Because I mean, I think in total there was like 40 or something like that cars sold, but I don't think that's what you're looking for, right?
No, so these are the data values, right?
Uh-huh.
These are the data values. And so we're looking at the frequency of cars sold per week. So remember when we add up, you add up all the values in the frequency. So you wouldn't total this up. It doesn't make sense to total this up. You're totaling up frequencies. So if we total up all the frequencies of, so like the total number of zeros plus the total number of ones plus the total number of twos plus the total number of threes, then what should that add up to? How many data values there are. Because this is telling us frequencies are how many data values that are 1, how many data values that are 2, how many data values that are 3. So if you add all those up, you're going to get the total number of data values. And then relative frequency then is percent or portion, right? What portion are 1s, what portion are 2s, what portion are 5s. So when you add all those up, you should get 1. Yeah, but it doesn't make sense to add up the data values themselves. So you wouldn't add the total of this first column.
I think I put like 6 or something because there's 6 different variables, 0 to 5.
That's not. There shouldn't be. There shouldn't be any question here of adding these up because it doesn't make sense. It's like us getting all our heights in inches and then adding all those up. What would that mean? It doesn't really. It's like if we all stood in a stack, that's how tall we would be, right? So it doesn't really make sense. But what makes sense is, seeing how many data values of a particular type there are and adding those up to get the total number of data values. Other questions? So that table is just a little bit, there shouldn't be even a box here. So maybe they should take this box away and then put totals here with a colon so that you're just only doing those 2. All right, so let's move on to chapter 3. Okay, so chapter 3 is descriptive measures. So this is numerical analysis. Numerical analysis are numbers that we can generate that describe a data set. So numbers that we can generate to describe a data set. So the first one is what we call measures of center. Okay, so I have a joke. So there's 3 statisticians, and they go duck hunting. Okay, so a duck flies up, and the first statistician jumps up, and he shoots, and he's 3 feet too low. And then the next statistician jumps up, raises his gun, and he shoots, and he's 3 feet too high. And the third statistician jumps up and says, "We got him!" So, what is this about? Measures of center. Measures of center. So the mean, median, and mode of a data set are considered measures of center. So what was the measure of center of the first 2 shots fired by the statisticians? What was the center? 3 feet too low, 3 feet too high. So if we were to measure the center of those two, it would be right on the mark, right? That's what the statistician was talking about. But of course, the duck flew away, right? All right, so a mean, median, mode of a data set are considered measures of center of data values. They're each a single value that often indicate what typical values in the data set are like. Remember, don't do word for word note taking. You gotta turn your brain on and listen and abbreviate. Okay, I can't wait for you to copy that whole thing down. Say below is the mean value of a sample of weights of 10 watermelons and a mean value of a sample of 10 grapefruit. Which is which? Which is which? So we got a mean or an arithmetic average of 0.7 pounds for one of the fruits and a mean or arithmetic average of 7 pounds for the other fruit. So this is indicating like around how much does each fruit weigh. So when we take an average, you're kind of like getting an idea of what the data values are like, right? So which fruit had a mean of 0.7 pounds? Grapefruit or watermelon? Grapefruit, right? Grapefruit. So grapefruits would be less than a pound, or maybe the big ones are a pound, okay? And then watermelons would be much heavier, right? Maybe 7 pounds. Okay, so this measure of center is kind of indicating what the data values are. It's like a 1. If you had one number to indicate what the data values are like, it would be a measure of center. You see? So the mean is you've all had your the mean of your test scores, right? You've all had test scores in a class, and you found your average, right? So the mean is the sum of the observations divided by the number of observations. Okay? The median is the middle data value. Okay, so it's the value such that half of the data is above it and half of the data values are below it. Okay, that's the median. And then the mode is the most common, or the data value with the highest frequency. And these are all potential measures of center or an indicator. These numbers are indicators of the value of the values in the data set. Mean, median, and mode. And most of you are probably familiar with this already, okay? Okay, so the mean is very straightforward. Like I said, you're going to add up all the data values and then divide by the number of data values. Okay, but the median is there's a little more to it. So for the median, we're trying to find that data value such that half of the values are less than and half the values are greater than. So if the number of observations is odd, then the median is one of the observations, right? Because you'd have an odd, there's one that's right in the middle. But if the number of observations is even, then there's 2 middle values, right? So what we do is we take the mean of the 2 middle values. We take the average of the 2 middle values. So then the median, if your number of observations is even, is often not one of the data values because it's a little average of those 2 in the middle. Okay, so let's just do a quick example here. So suppose the data for the grapefruit set was okay. So here's our data values. And what's the number of data values? So n we use for the number of data values in a set. So say n equals 7. So we actually, is one of these actually the median, or do we have to do the little average thing? Is one of those actually the median? Okay, and which one is actually the median?
First instance of 0.8 when you do it in ascending order.
So yeah, so we got to put them in some from least to greatest. And if n equals 7, so I'll go ahead and just put them in that order. So least is 0.6, 0.6, oh, 0.5, forgot 0.5. 0.6, 0.6, it's 0.8 next. Okay. And so if we've got 7, that means we're going to have 3, 1, and 3. And so if you have a really big data set, you can use this formula down here, n plus 1 over 2, and it tells you which one in the ordered list will be your median. So n plus 1 over 2, what do we do? We do 7 plus 1 over 2. What do we get? 4. So it's the 4th data value in ascending order. This, you don't really need, for a small data set like this, you don't need to do this little formula. But for a large data set, it would help. Okay? But basically with 7, we know it's going to be 3, and then the median, and then 3, right? You got the median and 3 data values above and 3 data values below. And so then that's where the 4th, that's showing us that the 4th, right there, is our median. So half of the data values are above 0.8, half of the data values are below 0.8 pounds. Okay, and then how about for the watermelons? So let's say for the watermelons we had I don't know. So what's n in this case? N equals 8. So we put them in order from least to greatest, and now there is none of those data values are a middle value. So there'd be 2 middle values. And what we do then for the even, so when n equals 8, we got an even number of data values, you're going to see the average of the 2 middle. So go ahead, put them in order, take the average of the 2 middle ones. And what did you get? This one, I know it. Did I get them all? So 2 middle ones are?
7.1, 7.2.
So therefore the median is the average of those 2. So it equals
7.15.
1.5. Now our formula also works here, because if we do 8 plus 1 over 2, what number do we get? We get 4.5. The 4.5 fourth, kind of, right? So it's the average of the 4th and the 5th, right? It's the average of, so it's right between 4 and 5. is our median at 4.5 right there. So the little formula works regardless of whether you have odd or even. Okay, questions on median.
What happens when you have two, when you, like you have an odd number and,
Uh-huh.
and the two numbers, the two median numbers you have to average are both the same number?
You mean even?
Yeah, like 22 and 22.
Yeah, then what's the average of the same number?
Be 22.
That's the same number, right? So if these were both 7.1s, your median 7.1. Other questions?
How are you getting what?
It's just the number of data values.
Oh.
It's just how many data values are in the set. Okay, so the mode is the frequency of every value. So to find the mode, you find the frequency of every value. And then if no value occurs more than once, the data set has no mode. So if you look at what you had for the watermelon example, that had no mode. All 8 data values were different. Did you see that? Okay, so that's no mode. So, the mode is so we need to start to have data values that are repeated. Okay, so any value that occurs with the greatest frequency is the mode of the data set. So there can be one mode, there could be 2 modes, there could be 3 modes, there could be 4 modes. So it's like if you have a tie for the greatest frequency, then you have multiple modes. Okay. So in the grapefruit data set, 2 modes, and the modes were so going back to the grapefruit data set.
0.6 and 0.8.
So for the grapefruit weights, so we call that's bimodal because there's 2 modes. And the 2 modes were? Tell me again. 0.6 pounds and 0.8 pounds. Now, notice the mode is the value of the data. It's a data value. It's not the number. It's not a frequency, right? The mode is not expressing frequency. It's expressing a measure of center. So it's expressing data value. So the mode is not 2 because there were 2 of each of those. The modes are 0.6 and 0.8 pounds. So like median and mean, the mode it's going to relate to values in the data set, right? It's going to be indicating what is the data set like. The mode is not frequency.
Okay, so you have a mode where you have 3 values that are the same,
Uh-huh.
and then 2 values are the same.
Okay.
Would that still be bimodal? Would
Is that
you still have
bimodal?
2 modes, or would it only be 1 mode because one has got more than the other?
2 or 1 mode? 1 mode. Yeah, because the one with 2 is not the most frequent value, so it's not a mode. So if you've got multiple data values that are repeated, you're going to go for the greatest or a tie for the greatest. So the 3 data values beat out the 2, so the 2 is out of luck. That's just 1 mode at that data value that had 3. Okay, so I want you to do a little work, practice here. Remember, always work, so you're going to work this way, put your name and the date, upper right-hand corner, working vertically. Okay, I have a follow-up question for data set 2. And the follow-up question is, which of the 3 measures, so you got 3 measures of center, you got the mean, the median, the mode. Which one of those would you use to indicate the expected price of a set of tires? Why? That's a follow-up question. So which one would you say, if you wanted to say, this is what you expect to pay for a set of tires, which one of those 3 measures of center would you use? And why would you pick that one?
It's like, what happens if you come in and they make you pay that? And like, you're gonna like have a really inaccurate representation of what you like.
What would you usually expect?
I don't know. The average price you pay.
Okay, so this is So this question is made to get you to think about what's happening here. So what did we get for the mean for data set 2?
Mean for data set 2 is $474.
474? Agree? Yes? Okay. What about the median?
$350.
And the mode?
300.
Okay, so I want to hear, what did you guys think about this question? Which one of those three? So those are all, mean, median, and mode are all values like data values, right? The data values, x's are variable, right? X's are variable. Here it's x equals 300, x equals 300, x equals 940, x equals 450. So x changes as you move from one data value to the next. Mean, median, mode are always values like values of x. They're indicating what the values of the data are. Okay? So if for mode, so suppose you're working through this 1, 2, and there's 5. If you got 5 for the mode, then that should be like warning lights, right? Because 5 is not a number like the price of tires. It's like, oh, I did something wrong. Oh, I put the frequency for the mode, not the mode. The mode would be 300 because it's like x. Mean, median, mode are values like x. They're values that compare to the data values. So now I want to hear some. Which one would you, if you had to pick one to say this is what you would expect to pay for price of tires? Which one would you say? Yeah, what do you think?
I would say median because
The median. Okay. Go ahead.
there's a couple like outlying like numbers like 1,050 and 940 and all, which I mean you could end up paying that much, but the probability of that happening is, I mean, not that probable. And so it kind of skews your data.
Okay.
And so the median I think is closer to the amount that you would most likely pay when you walk into a store and ask for tires or whatever.
Okay. Other arguments?
I said mode because it was the highest frequency. So
Mhm.
theoretically, if you went to 12 or 10 stores and half of them you paid 300 at, you're most likely to walk into a store that you're gonna have to pay 300 for.
Okay. Good argument. Yeah.
I would use the mean because it's the average of all the possible variables
Okay.
available.
Okay. So we got a vote for all three. One for each of the three. But so now looking at this data set, there's definitely let's see. So, would you expect to pay close to $1,000 for a set of tires? I mean, this is all given the fact that the you don't have a choice in the matter, right? So this is kind of like you going into the tire store and you spin the wheel and it's like, this is the set of tires you're buying, okay? That's how we have to kind of take this situation, okay? So that's not exactly realistic, but so the argument for median was a good argument, okay? The argument for median, because 350 is more like most of the data values, right? So they're all around 300, 400, 450, and so the mean is higher because of these values that are way kind of outside the norm, right? So they're what we call outliers. They're way outside the norm, and so it's pulling the mean up away from kind of the true center of the data. The true center of the data is more like the median or the mode here. So median or mode would be kind of your two better choices for what is the data actually like. The mean is like pulled up out of that range because of these two values that are kind of not ordinary. You see that? They're not ordinary. So best answer for this would be either the median or the mode, because they're more indicative of most of the data in the center place of most of the data. So maybe median would be the best choice because you got these all the 300, 400, 450. Maybe the median would be the best choice. The 475 it's greater than all of those, right? It's greater than all of those typical data values, the highest being 450. So do you see that the mean is kind of too high? And we talked about this last time with a shape of the distribution. This is a skewed distribution, right? Because the center is more around the median and the mode, And then we have these, what we call outliers, these two values that are skewing the mean out away from the kind of the true center of the data, or the true kind of most common values of the data. Would you buy that? Does that make sense? So you wouldn't expect to pay $500 for a set of tires. It's more likely you'd expect to pay $3 or $350 or $400, somewhere in that range. That's more what would you expect. And it's these two very high values that are skewing the data, pulling the mean. So is this right skewed or left skewed? Right, because you think of the values horizontally. The lower values are on the left, the higher values on the right. So those two high values are skewing the data to the right, to a higher value than the center. Okay, questions on that discussion? So now I just want to let you know that everything we do, we're going to spend a lot of time kind of going for understanding of what things mean, and that's what you're going to be tested on. So it's not just going to be find the mean, find the median, find the modes. This discussion we just had, you have to really understand that to succeed on the test, okay? So don't think it's just going to be all about calculating values. Interpreting is more important. Interpreting is because we got technology to do all this stuff for us. So now we become the managers of the data, so we have to understand what the data means and what our calculations mean. Okay, so here's another similar example. The mean starting salary of graduates in geography at the University of North Carolina in 1984 was $224,000. You think, oh, I'm in the wrong major, right? Okay, what's going on here? Someone knows what's going on here? Anyone else? Maybe? Okay, skewed by what? Anyone know how this got skewed? North Carolina, University of North Carolina in 1984. Anyone know anyone who might have graduated from? Michael Jordan graduated from North Carolina in geography in 1984, and so what was his starting salary? In the millions, right? He was in the millions. So then when you average together all of the geography graduates, their starting salaries, it comes out to $224,000. So good indication of what you would expect to get for your first job as a geography major? No, not at all, right? In 1984, maybe $30,000 or $25,000 or $35,000 a year would be much more typical of a graduate in some liberal arts degree. Okay, so again, it's the same thing happening again. You have this one value that's way outside the norm, and so if you look at the average, the arithmetic mean, it's not a good indicator of the typical data values in the set. It's pulling that average way up. So it's majorly skewed by this one outlier of salaries, Michael Jordan making in the millions his first year out of college. Okay? So here's the summary of skews. So right skewed means that we have some maybe outliers or high data values that aren't indicative of most of the data, pulling the mean up from the median. And then left skewed, we have some very low values, not indicative of most of the data, pulling the mean down from kind of the center of the data. So for a skewed data set, which of the measures of center are we gonna look at to be a better indicator of typical data values? What are we gonna look at? What's that? No. So we don't have a choice. So if we have a data set, it's going to be one of these three. We can't change the data. We can't change it to make it center. So suppose we have a left skewed data set. What are we going to look at for the best indication of the data values? Yeah. The median, right? So the median, what gets skewed is the mean. So the mean then becomes less indicative of what the data is really like. The median then closer, you see how the median's higher here, it's closer to where most of the data is. Okay, questions on that? So that's kind of a review. Okay, and then in these diagrams, what's the left and right axis again? Let's do this on your loop sheet. So I want you to explain, what does going left and right mean on one of these diagrams? And what's the height of the curve mean on one of these diagrams? Go. So this is for your sheet. You can work together. So what does the horizontal axis represent in one of these diagrams? What does the height of the curve then represent in these diagrams? Write it out. Okay, I will not go over that, so make sure you have this. You can work with each other, okay?
But those, do we consider horizontal and vertical axis?
Horizontal is this black line here.
Yeah.
That's the horizontal axis for each of these three different diagrams.
Lines and the blue lines.
Then you have what does it mean, the height on the curve? At a given point on the horizontal axis, then there's the height of the curve. What does that mean? So that's vertical, right? So vertically, what does the curve tell us vertically? Horizontally, what's the meaning of the horizontal axis? So if you're not sure, now we got to learn this and never forget it, okay? So talk with someone who knows what's going on. Horizontal axis, vertical axis in these graphs. What's the meaning of the horizontal axis? What's the meaning of the vertical axis, or height of the curve? Okay, we're gonna move on. If you're not quite 100% sure, find out. Find out. Ask me. Ask someone around you. So we got to nail that down. So we're gonna be looking at these pictures all semester, and so it has to be no hesitation as to the meaning of these diagrams. Okay. So here's just a technical. I showed you that this. So x is our variable, which takes on the different data values. So x bar is called the sample mean. The sample mean. So our sample is our data set. X with a bar over it is sample mean. So that's the sample mean. And then what is this? So this is n is the sample size. So x. These are data values. This is just some nomenclature here. This means sum. Okay, n is sample size. And then x bar is the sample mean. So xi, so I, and then so xi is all of these. When I is 1, you have x1. When I is 2, you have x2. When I is 3, you have x3. So all the data values. So generally, xi. So how do we find the mean? How do we find the average? You sum up, right? So, yep, you sum up. So this all should make sense. You sum up. That's sum. This is all the data values. x1 plus x2 plus x3 plus x4 plus x5 divide by the number of data values, and that result is the sample mean, or the mean of those data values. So that's just putting symbols on something you already understand and know, right? But you have to make the connection, right? You have to connect between these symbols and what you know as finding the average, say, of your test scores. It's the same thing. Sum up all the data values, add them all up, divide by the number of data values. Questions on that? Okay. So then the next thing we want to look at is measure of variation. We'll just start this and then we'll do most of it Friday. Okay, so the data sets below are bowling scores of 2 children. Both have a mean score of 50. What does that mean? A mean score. So they're both about 50-point bowlers. So having the same mean, is there a distinction between them as bowlers or not? So they both bowl around 50 on the average. Are they basically the same bowler or not? So they're shaking their heads. Why not?
Because you're not taking into account the individual scores.
And what could be different about the individual scores?
Somebody could bowl a better ball and get nothing, and somebody could bowl a strike and get all 10. So it's like.
No, but we're looking at their scores of their games. Their scores of their games. Both of them have a mean of 50. Mm-hmm. Both of them have a mean of 50. What were you saying? Okay, but we're just comparing their badness, right? So there's this one child is bad, and this child, is the child equally bad? They both have a mean of 50.
Is that like how consistently they're bad?
Okay, yeah. Consistency. Okay, so here is the dot plot of those 2 data sets I just showed you. They both have a mean of 50. So if they bowl a game, your best bet at what they're going to bowl is 50 for both of them. But are they the same bowler?
No.
The second bowler is how compared to the first? Like less consistent, right? The first bowler consistently bowls more near 50. The second bowler is more erratic, right? Erratic. They can have a really good game, but then they have a really bad game. Okay. So there's more to a data set than just what do you expect the data value to be. There's what's called the variation on the data, or the spread of the data. Is it consistently around the center, or is it all more spread out? So this is a different aspect of a data set that we're going to look at, like called the variation of the data or the spread of the data. So that's a preview for Friday.